Hey guys, welcome to Linear Equations. Okay, so you don't get to see my face this time because Camtasia is too slow on my computer, so you're just going to have to listen to my voice. Alright, so a linear equation has no other operations except for we've got addition, subtraction, and multiplication. And you want to be very careful with this multiplication. This is multiplication, we should be really careful and just say by a constant. Okay, so we want to say by a constant here, by a constant, okay, because you could say, well, multiply it by a variable by another variable, and that will change it from a linear to some other form. Okay, so what is a linear equation? You've probably seen them before. There's many different forms of these, so you can look at in like 3x plus 2y equals 7, something like this, or y equals 1 half x. You can even have x equals a vertical line here, x equals 5. And there's many different forms a linear equation can have. And you can change the variables here. So you could say, let's say 6x plus 3y equals 12. Okay, so there's different forms this can take, and you want to be careful because they don't always have to be, if you look here, x and y. Okay, I change it to s and y, t and v, whatever you're dealing with. T is a real common variable for the x, for the independent variable, so just be careful with that. They don't have to always be x and y, so you can change the variables. Nonlinear equations, those are a little bit easier to see, and they can also be different variables. You're really looking for things that have a different power than x. So let's say we have 7a plus 4b squared, and that's equal to negative 8. So if we look at that, and you can notice here, right there on the squared term, okay, that is a squared term, so that's something that's not linear. We can look at a very common example after we study quadratics is square root functions. We could look at the square root of x minus 4. Okay, that is not going to be linear. You could say x plus x times y equals 1. Okay, and you have two different variables being multiplied together, so if you're looking at this particular example, you'd have a problem with this right here. There's where your issue would be, two different variables being multiplied, and that's where we get this idea of constant when I wrote it up here, so by a constant. Okay, and one more example, when we get into study rational functions and reciprocal functions, 1 over x. Okay, that's the same as if you wrote x to the negative 1, so that power is not 1 on x and y. So hopefully now you see the difference between the two types of equations. Okay, so let's keep moving on. When you get into what a linear function is, so you go from a linear equation, a lot of it just has to deal with notation. Okay, they change your y value, your output to f of x. That's function notation. And a linear function is a function whose ordered pairs, so the ordered pairs satisfy the equation. So your ordered pairs satisfy a linear equation. What that means is that when you plug in your ordered pairs, you get a statement that's true. Okay, so in example 1, which of the following are functions? So I'm looking here, I have 10 minus 5x, okay, and I look at the power here, I can circle this, and there's only a variable here, and that's to the first power. So yes, this is a function, okay, lines are functions, okay. So yes, this is a function, it is linear, it is in slope, it's intercept form, the variable is to the first power. Okay. Now, when you get into the second example, we're going to look right here and say, wait a minute, that's to the fourth power. That's really 4x is being multiplied out. Okay, so there's our troublemaker right there. So we're going to say, no, this is not a function. Okay, and the reason being is x is being multiplied by itself. X is to the power of 4. Okay, and they need to be the first power linear equations, okay? And lastly, you look at h of xy. Now this is great notation. This is in terms of two variables, okay? X and y, so that's why we have the x and y in here, not just x. So this is in terms of x, this is in terms of x. This function, or we think it's a function, is in terms in x and y, and you can see the problem right there. Two different variables are being multiplied, so no, this is not a function. So no, we could say two variables are being multiplied. Okay, I'll just abbreviate there, being, whoops, multiplied out. Okay. So when we go on into our next example, we have what we call standard form. That's one of ways we can write a linear equation. A and B are real numbers, so that's important to realize. A and B are elements of the real numbers. A, B, and C are real numbers. A, B, and C are elements of the real number system. A or B can be 0, but they can't both be 0 simultaneously. Okay, so in our second example here, they want us to write each equation in standard form. So we want this. So we want the A x term and the y term to be on the same side. Notice here how y and x are on different sides. So that's a pretty easy fix. I'm just going to add the 2x to both sides. Okay, so I'll add 2x to both sides. And I think that's pretty much all we're going to have to do. So we have 2x plus y equals 3. That is standard form. So when you write in standard form, get your variables on both sides. So here we have a constant. It might be easier to get rid of that 5 first. I'm going to multiply everything by 5. I don't like that 5 there. You can leave it, but it would be really nice. So now we have negative 3x equals 15y minus 10. So that's a little bit easier. So I'm going to bring over the y term. So I have minus 3x minus 15y equals negative 10. And so if I divide or multiply everything by negative 1, because everything's negative here, I get plus 3x plus 15y equals 10. So the second one was a little more work, but that's how you rewrite equations in standard form. Okay, let's move on. And so now a couple last things we have to look at are x and y intercepts. And those are important because when you graph standard form equations, you're looking for the intercepts. Okay, so the x-intercept is where your function is going to cross the y-axis or the x-axis. So the x-intercept is the x-coordinate of the ordered pair that crosses the x-axis. The y-intercept is the y-coordinate of the value of the point that crosses the y-axis. Okay, so the big key here is when you look for the y-intercept or the x-intercept, you set y equal to 0 always. So set y equal to 0. If you want the y-intercept, you set x equal to 0. And then we solve. So we'll find two different order pairs. So find the x-intercepts and graph. So if I want the x-intercept, I'm going to say 3x minus 4 times, and what we're going to do is plug in 0 for y. Okay? Because we want the x-intercept. So now we're going to have 3x, let's combine steps. 3x, the 12 has got to go over here. So that's going to equal negative 12. So x equals negative 4. That's the x-intercept. So the ordered pair is negative 4 comma 0 because we set y to be 0. I don't know if we'll have enough space to graph, but we'll try. So the y-intercept here is the same thing. We set x equal to 0, and we'll have minus 4 times y, and we'll say equals negative 12. We'll simplify that up. So negative 4y equals negative 12. So y equals 3. So then we have 0 comma 3. So those would be the ordered pairs we plot. We're going to run out of space. We'll try right here. Okay, and we're going to plot 0, 3, 1, 2, 3, and 1, 2, 3, 4, 0. We'll make it in red. So we'll make our point. There's negative 4, 0, and 0, 3. And this will be hard with the tablet. Oh, I almost got it. Almost made it. That graph, there's our line, should be going through that. It's hard with a tablet to do. Okay, so that's how we graph standard form. You're looking for the intercepts. All right, last example. In August 2000, the Russian submarine Kursk sank to the depth of 350 feet in the Barents Sea. The linear equation P of D equals 62.5D plus 2,117 can be used to find the pressure in feet per pounds per square feet at a depth of D feet below the surface of the water. Find the pressure at the depth of 350. So we're going to write our equation. So P of D equals 62.5 D plus 2,117. So by substitution, we have P of, and we're going to say 350, right? That's our depth. So 350 goes in. That's our new argument. Okay? And wherever we see a D, that's what 350 is going to replace. So we have 1D there. Okay, and we'll plug in 350. And then when you simplify, we'll use a calculator to do that. And we end up with a value that's approximately 23,992 pounds per square feet. In part B, the term 2,117 in the function represents the atmospheric pressure at the surface of the water. How many times as great is the pressure at the depth of 350 feet? Well, the idea here is you just take your answer from part A, 23,992, and you're going to divide that by the original 2,117, which is going to be approximately 11.33 times as great. Okay, so that's linear equations, guys. If you have any questions or comments, you can type them below or email me at nicholas.bennett@dc.gov.